everybody. I wanted to talk today about a matched pairs problem. So we have a problem here, and it says, do athletes training for a triathlon significantly improve their speeds on a 10-mile run by adding a 3-month yoga program to their workouts? Subjects were randomly chosen to be involved in the study, and then here are their following times in minutes before and after the program for each athlete. So I'm assuming that each one of these is a run time. And remember, when it comes to things like running or things with speed, a smaller number is a better time. And so that would mean that they went faster. So if you take a look at what we have 9 athletes, and we have a before list and an after list. And if we look down at the bottom here, athlete number 9, for example, ran 87 minutes before the program, and then after 3 months ran an 84-minute 10-mile run. And so we have subjects, and they were randomly chosen. And so really we have only just one sample, and that sample is 9 athletes. And the big question is, how did they do, right? And so now, before we look at which one we should decide, really, should these athletes be linked together at all? I mean, should the before time and the after time be linked together? And you say yes, because there's a difference between each one of these. And we can see that, like, athlete number 9 had a 3-minute improving time, ran faster, and athlete number 3 didn't run faster at all after the yoga and ran a 90 and then ran a 90 again. So that difference was a difference of 0. And so really, should these guys be linked? And the answer is yes, they all should be linked, because before and after should be linked because they all come from the same person. So if you're a slow running athlete, for example, athlete number 3 and number 4 run kind of slow, then their before time and their after time will probably both be kind of slow. But if you're a really fast athlete, for example, athlete number 2 runs really fast, that person ran an 80 and then a 74. If they run fast in the beginning, they probably will run fast after as well. And so we think that we should link those guys. And that's really the crux of why something should be matched pairs, is should those values be matched so that we can just look at the difference? And the answer is yes. So that being said, when we look at the difference, we really are going to do all of our math with just the list of the difference. We could really throw out the before list and the after list now that we have the list of the difference. And so I went ahead and ran a 1 variable stat just on list 3, which is where my difference is. And I found that the sample mean time of the difference is going to be 2 minutes and 11. And then the sample standard deviation, and then the n size. So notice all those little d subscripts means that it's of the difference list. And so you don't have to write them in, but a lot of people do, just to distinguish that you're looking at the difference, not the actual original times. Our degree of freedom is going to be an n-1, so we have a degree of freedom of 8. And our parameter of interest is going to be the true mean of the difference in times before minus after. Okay, nobody knows that answer, right? And so that's why we're about to do a hypothesis test on this. And we're going to base that mu d on that x bar d. And again, we're going to focus just on list 3. So even when we run a test or when we run an interval, it'll just be on the list of the difference. And so we're going to create our null and alternative hypothesis. Our null hypothesis is that there's really no difference. It didn't matter if they did yoga or not. The mean of the difference of times is going to just not change at all. But because of the word improve in the problem, if you improve, that means that the smaller amount of time should be on the after. And if I take before minus after, then I suspect I will get a positive number. So I expect the mu d to be positive or greater than 0. Had I subtracted the other way, then after minus before, then I would be getting negative values in general, and then I would make this mu d is less than 0. So really, it's based on how you subtracted and also based on the question that you were asked. So the first thing I want to start off with is it reasonable to do this problem at all? Does it go through the checks of the assumptions and conditions? So do I have randomness or good representation of the population? Can I sample without replacement? And do I have something that's approximately normal? And again, I have three choices. Is the shape originally given for the distribution? Can I use the central limit theorem, or do I have to graph this, right? So let's go back to the problem and reread it again. Yep, looks like random was given. They took a random sample of athletes, and then 90 is less than all triathletes. I think this is because they're talking about athletes training for a triathlon. I think I'm going to call them triathletes. The graph actually isn't skewed at all, and there are absolutely no outliers, so I'm good to go. I'm going to proceed with a match pairs T, and that's our formula. And I want you to notice that that formula is the exact same formula as just a regular t-test. If you go onto your graphing calculator and search for match pairs t, you won't find one because you already have just a basic t-test, and that's what a match pairs is. It's just a t-test. Same thing. It's just we're using a list of the difference, and that's it. All right, so if you just keep that in mind, that's the coolest thing about match pairs is you don't have to learn a new formula. Really, you don't even have to learn new conditions either because it's just for one sample. And also notice the other thing is that your null hypothesis is almost always 0, and so that in the numerator, that mu sub d is almost always 0. And we'll go ahead and plug those values in that we got from our list. And notice that gives us a t-value of like 2.8, which is kind of far on our graph, so I suspect our p-value will be pretty small. So I'm going to go ahead and proceed, draw the t distribution. I expected a mean of the difference to be at 0, but our sample mean of the difference was 2.11 minutes. And so how far is that away? It's about 2.8 standard deviations from the mean, and that will give us a p-value that's relatively small. So what's the chance my sample mean of the difference is greater than 2.11 minutes, given I was expecting a mean of the difference to be 0? It only happens about 1% of the time, maybe almost 2% of the time. So that's a small p-value, and since nobody gave me an alpha, I'm going to make my favorite little alpha, which is 5%. And notice our alpha is larger than p, so I'm going to reject the null hypothesis. Finally, I get to make my conclusion, right? And so, yeah, I think it is strong evidence to show that the yoga program does improve the 10-minute mile run speeds for triathletes. And again, my probability statement, there's a 1.15% chance of getting a sample mean of the difference of 2.11 minutes or more when expecting no difference. And then my decision, this is significant results to reject the null hypothesis. So I hope this helps a lot for you guys. One last synopsis is the decision between two means and one match pairs mean. If you think you have two groups and you have two means, then you should be using a 2-sample T. But if you think you have one group that should be matched together and you're looking at the difference first, then that would be mu sub d. That's when you would use a match pairs T. Otherwise, you would use a 2-sample T. All right, take care, everybody.